Okay, so this is the second version of the mimicry circuit that we have. This is the version that keeps track of the human's position in space, compares it with the agent's position in space, and the agent makes informed decisions based upon that. So firstly, what we have is very similar to the first version. Everything with the FEAGI side is the exact same. There's still an X and Y stimulus decoder that slowly builds up over time, a connection between the random inputs and the output on the screen, so that when an input is pressed, the agent knows what's going to happen. And we can see that over on the screen as well. So once that motor babbling has finished happening, we can disconnect that. And then we can start to give human stimulus, which will look like this, just a simple movement. And we will see that the FEAGI AI agent will slowly begin to move into the position of the human, trying to put itself into the exact same place. It's a little rough when it first starts, but over time it gets better. It's also better when the human has made a smaller input, but big inputs work too. So if I go all the way to the bottom right here, we will see that the agent will start to move into that direction. If I go back up to the top center, we will see that movement happening as well. So the main way that this all ends up working is that there is a vision center specifically for the human instance of the game, 64 by 64, that is grayscale. That is, again, like the same as the human side, broken down into an X and Y input. There's an input buffer and a reset signal, as well as memory of the last known position. But instead of having left options and right options, it just ands itself with the left and right options of the agent view to know whether or not it is within that field or not. So as if it was in the periphery of vision, for example. The same thing works for the y-axis, and then once that kind of connection is established, the agent learns to move left or move right, depending upon.